So very good evening, all of you students. Beta, today we are going to do Huckel rule and we are going to do the basics for Huckel rule. Now, look beta, whenever a carbon has four single bond, we call it as which hybridize sp3. Whenever it has a double bond, then we call it as which hybridize sp2. Now for Huckel rule, what is compulsory? Okay, chalo. I think Zoya has also joined, yeah. Zoya beta, now you just see this. If carbon has four single bond, it is sp3 hybridized, and whenever in carbon there is a double bond, then it is sp2. Now, Zoya, I have given you that hydrocarbon ka Xerox. In that, you have to open part 3. In part 3, there is, behind, ekdam behind, there is one page, Huckel's rule of aromaticity. We are doing that. Now, what is the condition for a compound to be aromatic? Now, in exam, they will give you one structure and they will tell you whether it is aromatic or non-aromatic or anti-aromatic. So, what are the condition for aromatic? कंपाउंड शुड बी व्हाट इट शुड हैव व्हाट हाइब्रिडाइजेशन sp2 हाइब्रिडाइज होना चाहिए कार्बन सबसे पहले sp2 हाइब्रिडाइज द स्ट्रक्चर शुड बी प्लेनर n4n+2. Okay, that is total pi electrons. This will be the pi electrons. They should be what beta 4n+2 pi electron should be 2, 6, 10, 14, 18. आपको ये नहीं समझेगा, but you just remember whenever I add this 4n+2 where n is the number of pi electron, it should come what beta 4n+2 is equal to pi electron. It should come 4n+2. Okay, total pi electron. Okay, should be total pi electron and n ka value should come what whole number. N ka value should come what whole number. Then only n will be whole number. Then only it is will be a aromatic. नॉन एरोमेटिक में क्या होगा अगर पहले कार्बन देखने का फर्स्ट यू हैव टू सी कार्बन इफ इट इज sp3 मतलब खत्म देन यू डोंट हैव टू लुक इनटू द पाई इलेक्ट्रॉन बट देयर इज वन इंटरेस्टिंग थिंग दैट इज एंटी एरोमेटिक एंटी एरोमेटिक में एवरीथिंग इज सेम बेटा लुक देयर विल बी व्हाट ओके sp2 भी होगा प्लेनर भी होगा बट n का वैल्यू विल बी फ्रैक्शन n का वैल्यू विल बी फ्रैक्शन now I will say sir we are not understanding anything don't worry now I'll give you one example now look here I will give you an example the structure two three things you should remember beta whenever in structure oxygen will be there and if oxygen will have lone pair then we'll count this as lone pair count as pi electron count this as pi electron कितना है lone pair इस पे one pair so count it as how many pi electron count it as 2 pi electron whenever there is a lone pair on carbon it will be also count as a pi electron 2 pi electron. Okay, but whenever there is a lone pair on nitrogen in a ring, do not count as lone pair. Do not count as pi electron. Do not count as pi electron. तो आप बोलेंगे सर क्या बोल रहे हो कुछ नहीं समझ में आ रहा है डोंट वरी look I'll give you one example in exam I'll give you this structure ओके और मैं आपको बोलूंगा क्या ये एरोमेटिक है या नहीं whether it is aromatic, anti-aromatic or non-aromatic. For aromatic beta, whenever we'll do aromatic, n का value for aromatic, मैं लिख देता यहाँ पे aromatic 4n+2 is equal to total pi electron जितना भी structure में total pi electron होगा that we have to write and after solving this n should be whole number n should be whole number then it is aromatic नॉन एरोमेटिक एंटी एरोमेटिक में क्या होगा सेम थिंग विल राइट 4n+2 is equal to total pi electron but n will be fraction I give you very simple structure Zoya beta say this thing Rhea beta you see this how many pi electrons are there this is pi bond or not tell me Rhea
Yes, sir.
pi so total one bond means two electron right beta one bond means how
Yeah,
many
so
electron
6 pi
so,
electrons.
so 6 pi electron okay now each carbon sp2 hybridized देखो बेटा Yes ना बेटा, whenever a double bond
Yes,
is there
sir.
then it is which hybridized, it is sp2, first condition इसने satisfy किया. Now second
Yeah.
condition what will write, 4n plus 2, total pi bond, pi electron कितने हैं बोलो बेटा, how many are there, 6.
6.
So 4n is equal to 6 minus 2. So 4n is equal to 4. So n is equal to 1. Therefore, this structure is what?
Aromatic.
Aromatic. Have you understood this? Right? Clear? Okay. Now, चिन्मय बेटा, see this structure. एग्जाम में मैं आपको ऐसा स्ट्रक्चर दूंगा बेटा. And I will tell you whether it is aromatic, non-aromatic और anti-aromatic. चिन्मय बेटा, पहला सब कार्बन पे देख, सब कार्बन पे डबल बॉन्ड है कि नहीं बोलो.
हाँ
हाँ.
सर।
हाँ, तो डबल बॉन्ड है मतलब इट इज sp2, पहला कंडीशन सेटिस्फाई कर दिया. अब सेकेंड कंडीशन में हम लोग क्या करेंगे, 4n+2 इज इक्वल टू टोटल पाई इलेक्ट्रॉन. डबल बॉन्ड कितने नजर आ रहे हैं तेरे को बोल बेटा, ये और ये. एक डबल बॉन्ड मतलब दो इलेक्ट्रॉन होता है, कितना डबल बॉन्ड है.
सर 2।
हाँ, तो टोटल इलेक्ट्रॉन कितना हो गया, एक डबल बॉन्ड में दो होता है, तो टोटल कितना इलेक्ट्रॉन हो गया, 4. अभी तो सॉल्व कर, टू इधर जाएगा तो क्या हो जाएगा, एन का वैल्यू कितना आएगा बोल बेटा.
हाफ।
हाँ, तो क्या ये
वन
होल
अपॉन टू।
नंबर है या फ्रैक्शन है बोल.
फ्रैक्शन है।
फ्रैक्शन है तो ये क्या हो जाएगा.
एंटी एरोमेटिक।
हाँ, एंटी एरोमेटिक. क्लियर. जोया बेटा, हेलो.
Yes.
Okay, now you see the structure. I am giving you this structure and I have written here lone pair also. Right, beta? Now, what is the rule here? Everywhere is carbon. Can you see, beta? Now there is a double bond also. So this double bond means, okay, so carbon is which hybridized? sp2 hybridized. Which hybridized?
sp2.
sp2. Now, we have written one condition, beta. Do you remember, beta? If there is a lone pair on oxygen, if there is a lone pair on oxygen, we consider it as a pi electron. And if there is a lone pair on carbon also, we consider it as what, beta? Pi electron. Right? So, in this structure, is there any lone pair on carbon? Look, this is carbon. There is a lone pair or not? Tell me.
Yes.
So, this will be what? Your pi electron. So, here there are two. And this double bond also has 2. So total what you'll get? So 2 plus 2. So how many pi electron will get? 4. So 4n is equal to 4 minus 2. Therefore n is equal to again half I'll get. So this is again what? Tell me beta, if you get n ka value fraction, it will be what?
Anti-aromatic.
Anti-aromatic. Okay. Rhea beta, I'm giving you one structure here. Look. Rhea, each carbon is sp2 hybridized or not? Tell me first.
Yes, sir.
So first, each carbon is sp2 hybridized. Second, whenever there is a lone pair on nitrogen, will we consider it as a part of pi electron?
No.
No. So how many pi bond are there total?
6 electrons.
So what I'll get? So 4n is equal to what? So n is equal to 1. So it is a whole number, therefore it will be what? Aromatic or not? Tell me dear.
Yes, sir.
Aromatic. Have you all understood this? Chalo. Suppose beta I gave you this structure. चिन्मय बेटा, यहाँ पे सब कार्बन देखिए कि सब कार्बन है बेटा, कार्बन 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 का. क्या सब कार्बन पे डबल बॉन्ड है क्या.
नहीं सर।
नहीं है बेटा, ये वाले पे डबल बॉन्ड नहीं है, दिख रहा है ना ये वाला कार्बन पे. तो ये वाला तेरा कौन सा हाइब्रिडाइज्ड है, sp3. sp3 या तो फिर पाई इलेक्ट्रॉन को देखने का ही नहीं, क्योंकि इस पे सब सिंगल बॉन्ड होते हैं बेटा. sp3 है बेटा, तो अगर sp3 होगा तो क्या होता था बोलो बेटा, मैंने बताया था अगर sp3 होगा तो तुम्हारा क्या हो जाएगा बोलो। देखना sp3 होगा तो क्या हो जाएगा, नॉन एरोमेटिक, क्या हो जाएगा।
नॉन एरोमेटिक।
हाँ, वेरी गुड। जोया बेटा, आई एम गिविंग यू दिस स्ट्रक्चर इन एग्जाम. First, tell me, is here each carbon is having double bond or not? Tell me, dear.
Yeah.
So, first condition is there sp2. How many pi electron are there total? Count the red bond. All the red bond are pi or not? Tell me, dear.
Yeah, there's 5.
Hmm. So, 5. So, 5 means how many electron total?
10.
10. So, 4n is equal to 10 minus 2. So, 4n is equal to 8. Therefore, n is a whole number or not? Tell me, dear.
Yes.
So, it is what?
Aromatic.
Very good. Okay, so now all the structure I have given to you all, but I wanted to explain you in detail, so therefore I gave you here like this. Now, if you see here, I have given you this structure, beta. Now, Rhea, I want you to see this, beta. Hello.
Yes, sir.
Look, Rhea, we did this, right?
Hmm.
Okay, so it was sp2 and 4, and so n was 4, so it is aromatic. Then look, beta, here all are double bond, but this carbon is not having double bond. So here it is directly sp through, so non-aromatic. Got it?
Yeah.
Here also, if you see second structure, these were pi bond, but here this carbon was single. Can you see? So
Hmm.
non-aromatic. Now this we did right now. Look, we got n ka value 2, so it is aromatic or not? Tell me.
Yes, sir.
We did this also, beta. Look, it was sp2, yes, but n was coming what? What was the value of n, beta? Whole number or
Half.
fraction? Fraction, na?
Yeah.
So anti-aromatic. Clear?
Hmm.
Okay. So now, and here, all this structure we have done, beta. Look here. This was beta, can you see directly carbon sp3, so non-aromatic. This we did na, nitrogen ka lone pair will not consider as a pi bond. We'll consider only this red one. Can you see this? Hello.
Yes, sir.
Ah. Now beta, chalo beta. We did this also beta. Remember beta, whenever on carbon there is lone pair. So how many look, this is also sp2, 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 and this is also what beta, your sp2. Right beta? So and then there are pi was 6, n ka value was what? 6 aromatic. Is this clear? Right?
Yes, sir.
Chalo. Chinmay beta, I am giving you this structure. Look. Okay, Chinmay beta, this is carbon. All carbon are sp2 or not? Tell me.
यस सर।
Yeah. अच्छा, अभी ऑक्सीजन पे एक लोन पेयर है और यहाँ पर भी है। ऑक्सीजन का लोन पेयर को क्या करने का बोलो बेटा, गिनने का कि नहीं गिनने का, देखो।
हाँ सर।
अरे किधर गया? अरे, या ऑक्सीजन पे लोन पेयर होगा तो काउंट एज अ पाई इलेक्ट्रॉन। तो कितना आएगा बेटा तेरा, 4n प्लस इसका वैल्यू?
6।
वेरी गुड, 6 आएगा तो बेटा क्या हो जाएगा बोलो। तो ये एरोमेटिक
एरोमेटिक।
है कि नहीं बोल।
हाँ।
वेरी गुड. Is this clear? Right? Now, beta, we go to what? Beta, we have done preparation of benzene last class. Do you all remember? Okay, you will say, sir, where it was. So I'll just show you, beta. Look, this I wanted to do this aromatic thing, so I have taught you this aromatic. देखिए बेटा, ये अभी मैंने करवाया था ना बेटा. Hello. We did this, beta. Can you see aromatic? अच्छा, इसमें बेटा ये देख रहा है बेटा. हाँ, this I wanted to teach you, beta. This. अच्छा, come on. Hey, can you see this is only carbon, but here it is positive charge. मतलब it has only 3 bond. So it is sp2 hybridized. This is also sp2. So 4n plus 2, what I'll get, beta? Okay, let me draw this and show you. Let me draw this and show you. Zoya, if you see this, I have given you this, and I'm telling you whether it is aromatic or not. Carbon can form four bonds, right, beta? But I have written plus, so it is forming only how many bond here now? One bond. So three sigma bond. So sigma number of sigma bond is sp2 hybrid. Number of sigma bond is how much total? Three. So it is sp2 hybridized or not? Tell me, right? This is also sp2. This is also sp2. Now, how many pi electron are there? Zoya, tell me.
Um,
Only this bond is there, right, beta?
yeah.
So how many electron will be there, beta? Two electrons. So 4n plus 2. So what I'll get? 4n is equal to 2 minus 2. So 4n is equal to 0. Therefore, n is, n will be also 0 or not. So 0 is a whole number or not? Tell me, dear.
Yeah.
Therefore, it is aromatic. Clear? Right? So look, beta, we have written here. This is aromatic. Okay? Any difficulty till here? I hope all of you have understood. Now we are again going behind. थोड़ा आप बोलेंगे सर ऐसा क्यों किया? Because I wanted to do this aromatic first. फिर हाँ. Look बेटा, Zoya, we have this aromatic compounds का heading होगा वहाँ पे, उसमें थोड़ा आगे जाओ. चिन्मय, Rhea, we have done this beta. Look, if I take three molecules of acetylene, come by, this is, now look, first method of preparation beta. Sodium benzoate, chlorobenzene, acetylene. So I'm going to do from acetylene. Look, if I take three molecule of acetylene, what will happen, beta? This double bond, it will undergo polymerization. So one bond will shift. Can you see this way? So look, basically here there is a two electron, beta. Okay, so two electron था, एक इधर जाएगा, एक इधर जाएगा. यहाँ पे भी बेटा ये पाई बॉन्ड ब्रेक होगा. This will go here, this will go here. Pi bond will break. This will go here, this will go here. So I'll get here two electrons here, two electrons here, two electron here, and this will all join. And I'll get what? Benzene. So we are doing preparation of benzene. So this is how I'm going to get benzene. Clear? So now three molecule of acetylene or ethine are combining in presence of red hot iron tube. So three molecules will come together. So we call it as cyclic polymerization or cyclic trimerization or aromatization. So if you see in my notes, you can see this. If this H is missing, please make this H here. रिया बेटा नोट्स में ये H है कि नहीं है बेटा देख तो ये H होना चाहिए था ना यहाँ पे देख ना ये H
Yes,
रिया
sir.
it is there or not in the notes
It's not there in mine.
हाँ तो प्लीज मेक दिस H
Okay.
Chinmay Zoya or you all also make so this is how we got benzene. Now if I take beta propine if I take propine में what extra I'll get beta this CH3 will be there. So if I take three molecules of propine again beta this H was missing so please make this H beta. अरे बेटा ये देख ना वापिस ऐसे ही ज्वाइन हो जाएगा यहाँ पर देख रहा है कि नहीं. So here H I want you to make this H. So you will get what benzene 1 पे methyl 1 2 3 4 5 6 1 पे methyl 3 पे methyl 5 पे methyl 1 comma 3 comma 5 trimethyl benzene. It is also known as mesitylene. It is also known as mesitylene. Is this clear?
Yes, sir.
Okay. Then beta we prepare it from what? Sodium benzoate. Okay. Zoya beta, if you take this COH and this benzene ring, we call it as benzoic acid. We call it as which acid? Benzoic acid. Now from benzoic acid, if I remove this H, it becomes benzoate. It becomes benzoate. Like from acetic acid, we remove H, it becomes acetate. Now I'm adding here sodium. Therefore, it will become sodium benzoate. So this is your sodium benzoate. And I'm taking soda lime. Remember, beta, when you take soda lime, what will happen? This part will react. Na2CO3, right? And this H will go here. and you get benzene. Clear? So this process is known as decarboxylation. In your 10th grade also we have studied about this. Decarboxylation of sodium benzoate. So I'll just show you beta decarboxylation of sodium benzoate. Look here. This is your, look beta, this is your H. Suppose if I write here H, it is known as benzoic acid. It is known as benzoic acid. Now from benzoic acid I remove H and I add sodium. So it becomes sodium benzoate. Then I add NaOH and COH. This is known as soda lime. So this soda lime. Why we use soda lime? Why not only NaOH? Because NaOH is deliquescent. It will absorb moisture. So calcium oxide act as a drying agent. It will prevent it to absorb moisture. Now what will happen here? Look, this benzene and sodium carbonate will get. Clear? Next method of preparation. That is from phenol. Phenol. So from benzene, if there is on benzene ring, if there is OH, we call it as phenol. Look, this is phenol. If I take zinc, zinc is a reducing agent. What it will do, beta, it will remove this oxygen. So you will get, so zinc and oxygen will go and you will get, right, beta, zinc oxide. And what else will remain, beta? Benzene. So this is known as reduction. Okay. So from phenol also we got what? Benzene. Okay, so this also I have given here in your notes. Can you see this? Right? Now from chlorobenzene, if you do reduction, so one H will go here and one H will go with Cl. And look, can you see two H were there? So you get HCl and benzene. A reduction. From benzene sulfonic acid, if I do hydrolysis of benzene sulfonic acid under pressure, so this will become H2SO4. And you get what? Benzene. Desulfonation. Acetylene we did beta. Okay. Aromatization. Aromatization we have done where? We have done in alkane. Remember beta, we take hexane and hexane and then we heat in presence of aluminum oxide and 773 Kelvin. So what you will get beta? You get cyclohexane and when you further heat it, you get what? Benzene. Remember this was the last reaction of hydrocarbon, alkane ka. Aromatization. Now we have done all the reaction of benzene preparation. You will say, sir, you have not given, Are, this reaction is in alkane part. Okay. Now, beta, we have to study the reaction of benzene. Now, benzene is a very special case. Benzene can undergo substitution reaction as well as addition. But it will undergo substitution reaction willingly. उसको अगर लाइफ में मौका मिलेगा तो वो सब्स्टिट्यूशन में जाएगा rather than addition. Here it will go willingly and it will go unwillingly. Benzene does not undergo addition reaction unlike other. Why? Because addition reaction will destroy its aromaticity. Benzene is an aromatic compound, na beta. So therefore it won't prefer. So it will prefer substitution because if undergo substitution, aromaticity is not broken down. But अगर वो एडिशन होगा तो वो डबल बॉन्ड ही गायब हो जाएगा तो पाई इलेक्ट्रॉन ही गायब हो जाएगा ना बेटा. So now we are going to study first. Then to beta under certain condition it will go addition reaction also. So first I'm going to teach you addition reaction, ozonolysis, chlorination and hydrogenation. So you'll say, sir, where you have given this? So look, I have given here. Look, chemical property of benzene, addition reaction. Can you see here? Right? So what will happen, beta? Look here. It will go substitution reaction willingly. But addition reaction, it will go unwillingly. Benzene does not undergo addition reaction. Why? Because in benzene beta, what is there beta? Pi bond is not fixed, so it keeps on moving. Okay, does not undergo addition reaction. So here you can write, because it will destroy its aromaticity. Aromaticity. Please write this beta. एक sentence लिख लो चिन्मय बेटा, जोया बेटा. Please write this because it will destroy its aromaticity. Why it will undergo substitution reaction? Because if you see this pi electron beta, it can be either on the left or on the right. तो ये रिंग के अंदर गोल गोल घूमेगा, तो बेंजीन रिंग इज अ रिच सोर्स ऑफ इलेक्ट्रोफाइल। तो यहाँ पे इलेक्ट्रॉन ऐसा गोल गोल घूमेगा तो इलेक्ट्रॉन विल बी अवेलेबल। तो नेगेटिव पे कौन अटैक करेगा बेटा? इलेक्ट्रोफाइल आ जाएगा इधर पे। So now let us study the reaction. Addition reaction. It will undergo addition reaction under what beta? Special condition. Benzene may undergo addition reaction. तो addition reaction करते हैं, चलो बेटा एक एक करके रिएक्शन में बताते तुमको। Addition. Okay बेटा, I'll do a hydrogenation बेटा। Look, if I add hydrogen, so what will happen? बेंजीन का ये सब डबल बॉन्ड गायब हो जाएगा और सब सिंगल हो जाएगा बेटा। देखा, हमने हाइड्रोजन आइल ऐड, कितना डबल बॉन्ड है चिन्ह में बेटा? हमने डबल बॉन्ड आर देयर चिन्ह में, हमने
Three.
डबल बॉन्ड आर देयर थ्री ना। So,
Yes, sir.
so how many times hydrogen I'll add? Three times. And it will become what beta from benzene? It will become, look, this H, एक H, दो H, तीन, चार, पाँच, छः, cyclohexane. What it will become? Cyclohexane. Clear? So we'll say where this reaction is given, beta, look here. I've showed you here the very first. Can you see? I've added three hydrogen at three different places. Look, ये यहाँ पे H में ऐसा ही करना है, लेकिन ये मैंने आपको बताया, एक H इधर जाएगा, एक इधर जाएगा, एक इधर जाएगा, एक इधर जाएगा, एक इधर, ये दिखा है ना एच। और देखो आपको ये मिलेगा साइक्लोहेक्सेन C6H12 साइक्लोहेक्सेन। Similarly, I'll do beta chlorination. Similarly, I'll do what? Chlorination. क्लोरीन, तो क्लोरीन में अंडर यूवी लाइट अगेन सेम थिंग विल हैपन बेटा। तीन तीन जगह पे क्लोरीन आएगा, क्लोरीन क्लोरीन क्लोरीन, तो टोटल सिक्स क्लोरीन विल कम। एंड दिस, इसके बारे में एग्जाम में पूछते हैं, बेंजीन हेक्साक्लोराइड, because it is derived from benzene, so we call it as benzene hexachloride. This is very, very important. They will ask, what is the gamma isomer? What is the another name of BHC? Gamexane, or it is also known as lindane. It is also known as lindane or gamexane. So look here, I have given you yet. Look, this is my benzene, chlorine. How many? One, two, three, four, five, six. So three. I can write it there. I have written this in a split form. So how many carbon is here, beta? Six carbon. How many hydrogen? Count. One, two, three, four, five, six. So six carbon, six hydrogen, and six chlorine. Therefore, it is also known as 666. It is known as benzene hexachloride. It is also known as gamma-hexane. It is also known as lindane. In MCQ, they will ask, gamma isomer of benzene is called what? Gamma-hexane or lindane. Achha, it is used as an insecticide. What is the use of this lindane or benzene hexachloride or gamma-hexane? It is used as an insecticide. Insecticide. Then this is something new for you, that is ozonolysis. Ozonolysis. Ozonolysis means in first step we will add ozone. We'll first add what beta? Ozone. And in second step we add water to break it. So lysis. So now that is known as ozonolysis. Now this three oxygen we have taken ozone. This is beta. This is what your ozone. So if I take this ozone and if I write it here, three places, wherever there is double bond there, ozone will go, and you will get this benzene triozonoid. Three like this will get beta. Can you see? This was carbon, 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 carbon. This was over my benzene ring. So three places, one, two, three, one, two, three. I'll show you this beta here. So ozonoid, benzene ozonoid. Look. So look here, beta. What I have done here, I have done in a split form. Look. How many oxygen I was having? I'm adding three ozone. तो ये दिख रहा है डबल बॉन्ड, ये ब्रेक हो जाएगा, डबल बॉन्ड ब्रेक हो जाएगा, यहाँ पे ब्रेक हो जाएगा। सो आई गेट वन ओजोन हियर, वन टू थ्री। अरे बेंजीन पे एच था ना, ये एच एच ऐसे रहेगा, देख कार्बन के चार बॉन्ड होने चाहिए, वन टू थ्री फोर, ईच कार्बन फोर, ऑक्सीजन फॉर्म टू बॉन्ड्स, वन मोर ओजोन विल गो हियर, वन मोर ओजोन विल गो हियर। नाउ इन सेकंड स्टेप व्हाट आई डू बेटा? आई ऐड वाटर। So whenever I add water, beta, so this H2O and this oxygen, and this oxygen. So H2O plus this O will become what? H2O2. So how many times I'll have to add water? Three times. Why? Because there were three oxygen here. This will go and this will break. And now see the breaking properly. Rhea beta, look at this breaking. How it is breaking. Can you see this?
Yes, sir.
Okay. So look how it is breaking. Wait, I'll show you. So this is breaking like this. क्या हो रहा है हाँ ये रहा तो दिस विल ब्रेक ऐसा ब्रेक हो रहा है so this is CHO and this is also CHO can you see then one more breaking I am going to show you look here this breaking has not been shown properly ऐसा होगा बेटा CHO then again one more breaking this CHO 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 is aldehyde and this the blue oxygen three blue oxygen will go with 3H2 and it will give you 3H2O2. So this CHO you will get how many times? CHO, Rhea beta, CHO. How many times you will get beta? Three times. This CHO is nothing but what beta? Can you see this CHO? How many times you will get beta? Three.
3.
Three. Look here, I have written a three. So here also you can write. Yeah, but this CHO means carbon का ये क्या aldehyde. So it is two times aldehyde or not? So one carbon is methanol, two carbon is ethanol. But how many times aldehyde is there? Two times. So ethane diol. It is another name for this is glyoxal, 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 or ethane diol. Three times you will get. Okay, now why we use zinc? Because we got here three times H2O2. Hydrogen peroxide is highly reactive. It may destroy my product. So zinc will react with this hydrogen peroxide and it will make it inactive. I have written here. It will make it unreactive. Hydrogen O2 ko it will make unreactive. Hydrogen peroxide is highly reactive, na beta? So bus only three addition reaction. That's it. Now which reaction it will go willingly, beta? Look, beta, this will break and you get three times glyoxal. Zinc is used, which avoid further oxidation of glycol because of with the H2O2. Now, beta, we go for the next. It undergo which reaction? Electrophilic. Willingly. Now, this will go willingly. Substitution reaction addition. Willingly and this is unwillingly. I told you, beta, benzene does not undergo because it will destroy aromaticity. But it will undergo electrophilic substitution and nucleophilic also. Electrophilic, beta, it will go right? It is electron rich, so it will prefer to undergo which reaction? Electrophilic. Okay? Electrophilic substitution, it will undergo readily. Why? Because benzene ring is electron rich. Why? Because it has 6 pi electron. Pi electron andar ghumega, so it is a rich source of electron. So now let us do the first reaction. Halogenation. What is beta electrophilic substitution reaction? First of all, I'll tell you beta. Whenever hydrogen is replaced from benzene ring, whenever hydrogen is replaced by any functional group, new functional group, whenever hydrogen is replaced by new functional group, can you see? यहाँ पे हाइड्रोजन गायब हो गया कि नहीं? हाइड्रोजन की जगह पे नया फंक्शनल ग्रुप आया कि नहीं? तो वी कॉल इट एज इलेक्ट्रोफिलिक सब्स्टिट्यूशन. Electrophilic substitution reaction. Clear? Now, in an electrophilic substitution reaction, electrophile should be generated. There are various ways in electrophile can be generated. Whenever I take chlorine beta, whenever I take chlorine ka reaction, then what will happen? I'll take AlCl3. Aluminium chloride के बाहर कितना इलेक्ट्रॉन है बोलो बेटा 6. So it is an incomplete octet or not? So it requires two more electrons. So what will happen? ये जो क्लोरीन है ना इसका ये दोनों इलेक्ट्रॉन ये ले लेगा तो ये नेगेटिव बन के चला जाएगा और ये क्लोरीन पे पॉजिटिव चार्ज तो व्हाट आई विल गेट Cl विथ पॉजिटिव दिस इज इलेक्ट्रोफाइल chlorine with positive charge any electrophile with positive charge we called as onium so it will be chloronium and what else I got beta this AlCl4 I'll get or not tell me ये तीन था ना एक दो तीन और एक ये क्लोरीन आएगा so AlCl4 minus why minus because this chlorine का negative charge clear so what was the role of AlCl3 it helps to generate electrophile एग्जाम में पूछेगा it helps to जनरेट इलेक्ट्रोफाइल। अगर ये होता ही नहीं तो ये क्लोरोनियम बनता था क्या? नहीं ना। हेल्प्स टू जनरेट इलेक्ट्रोफाइल। सो लुक हियर। So first reaction I'm doing. So these many reaction we are going to do: halogenation, alkylation, acylation, nitration, and sulfonation. So first we do halogenation. Look, beta, if I take UV light, look, can you see I take aluminium trihalide and this halogen. So this 1x will, अरे ये दोनों इलेक्ट्रॉन ये खा जाएगा ना बेटा, देख. It will eat up and it will generate electrophile. Right? So let us start. Look, I'll show you this reaction. So this H and X will react. You get HX, and this electrophile will go. Look, hydrogen has been replaced by a new functional group or not? Zoya beta, whenever hydrogen is replaced by a new functional group, it is electrophilic substitution reaction. So if I take chlorine, so what was the role of this AlBr3? It helps to generate electrophile. FeBr3 or AlBr3, it helps to generate electrophile. So I am doing chlorination. Look here, AlCl3. So HCl, this HNCl will go, or H will be replaced by chlorine. Who generated this electrophile? AlCl3. So therefore, look how it generates. Look, I've given generation of chloronium. AlCl3. देखो ये AlCl3 होना चाहिए था, यहाँ पे error है बेटा. This is AlCl3. So this will take up both the electron. So and this chlorine will develop with charge positive. देखो बेटा. This will go. Now can you see chlorine positive बना and AlCl4 minus बनेगा बेटा. ठीक है. AlCl4 माइनस, अरे माइनस बनना बेटा. देखा. So this electrophile has been generated. So we'll say, where have you given this reaction? Look here. So look, I have given the heading also, beta. Look, whenever hydrogen is replaced by a new functional group, we call it as electrophilic substitution. Electrophilic. Why benzene prefer under a substitution? Because it is electron rich. So now first example. जिनमें बेटा पहला रिएक्शन देख बेटा, ये बेंजीन और क्लोरीन के साथ है कि नहीं, बोलो बेटा. अरे बेंजीन और क्लोरीन है कि नहीं?
हाँ सर।
AlCl3 का क्या काम था? इट हेल्प्स टू जनरेट इलेक्ट्रोफाइल. देख रहा है बेटा, ये दोनों ये पूरा ये दोनों इलेक्ट्रॉन ये ले लेगा और AlCl4 माइनस बन जाएगा. और ये क्लोरोनियम बना के नहीं तो देखिए H और Cl चला जाएगा और क्लोरीन उसकी जगह पे आ गया. देखो, हाइड्रोजन इज रिप्लेस्ड बाय दिस. सो इफ आई डू ब्रोमिनेशन देन, रेया बेटा, इफ आई डू ब्रोमिनेशन देन व्हाट विल आई डू? कम ऑन. I'll use AlBr3. So what will
Yeah.
happen? This HBr will go and bromine will come here. So you get, better this benzene ring is missing. Please make this ring.
Okay, sir.
Bromobenzene. But what will happen if I take excess Rhea? Excess लेके तो क्या होगा बेटा? All hydrogen will be replaced. Benzene में how many hydrogen are there? So all
6.
hydrogen are, but hydrogen is replaced by a functional group, then it is electrophilic substitution or not? Tell me. So you get
Yeah.
hexachlorobenzene. If they say in exam with excess chlorine, then only will. Okay. Iodination is not possible. We have done now because HI ka bond length is bigger. Right? Direct iodination not possible. Now we are doing nitration. Zoya beta, nitration में what we take first? Nitrating mixture. What is nitrating mixture? In exam they will ask. It is mixture of concentrated nitric acid and sulfuric acid in the ratio of 1:2. So look, can I write nitric acid this way? Zoya HNO3 होता है ना, ये ऐड करेगी तो. Can I write H2SO4? How many molecules I have taken, beta? Two molecules. Or if you add this up, you get H2SO4 or not? Tell me. Now,
Oh.
what is the role of nitrating mixture? Zoya, nitrating mixture helps to generate electrophile. How electrophile is generated? Look, these two will react among themselves when they generate which electrophile? Nitronium. Now, Zoya, can you see I have written here nitric acid in presence of concentrated. These two things were there or not? Now, what will happen, Zoya? Here HNOH will go. It will become what? Water. And this electrophile will go and attach here. You get nitrobenzene. Zoya, are you there, dear? Hello. H is replaced by nitro group or not? Tell me, dear.
Yeah.
Yeah, so it is whenever hydrogen is replaced by a new functional group, it is a electrophilic substitution. Okay, who generates here? Here, who is the electrophile in this reaction? Nitronium. Who generated it? Nitrating mixture. They react among themselves and they generated this. What is nitrating mixture? Ratio of concentrated HNO3 and H2SO4 in the ratio of 1 is to 2. This is 1 and this is 2. Can you see? Now we go to sulfonation. चिन्मय बेटा सल्फोनेशन सल्फोनेशन में हम लोग क्या यूज करेंगे बेटा सल्फ्यूरिक एसिड सल्फ्यूरिक एसिड को मैं ऐसे लिख सकता H2SO4 बेटा कैन आई राइट इट दिस वे बेटा स्प्लिट करके जिनमें
हाँ
देखना
सर।
H2 हो गया एस एक है एक एस O3 और एक O4 हो गया अब बेटा यहाँ पे देख बेटा ये पानी बन के चला जाएगा और SO3 ऊपर चला जाएगा यहाँ पर दिखाई दे रहा है दिस इज बेंजीन एंड दिस इज सल्फोनिक एसिड now in this reaction can you see beta hydrogen is replaced by sulfonic acid group or not tell me
यस सर।
बट बेटा अभी है ना एग्जाम में ना बच्चे मिस्टेक करते दे राइट इलेक्ट्रोफाइल इज SO3H नो बेटा यहाँ पे SO3H इज नॉट एन इलेक्ट्रोफाइल इलेक्ट्रोफाइल इज सल्फर ट्राइऑक्साइड ये बहुत इंपॉर्टेंट है रेया बेटा ये बहुत इंपॉर्टेंट है सल्फर ट्राइऑक्साइड इट इज क्लियर
Yes, sir.
नाउ बेटा वी गो टू फ्रिडल क्राफ्ट अल्काइलेशन व्हाट इज द नेक्स्ट रिएक्शन बेटा फ्रिडल क्राफ्ट अल्काइल मींस आई एम गोइंग टू ऐड अल्काइल ग्रुप राइट नाउ टेल मी बेटा या हाइड्रोजन की जगह पे तेरे को अल्काइल ग्रुप मिला के नहीं बोल बेटा मिथाइल ग्रुप right Rhea if hydrogen is replaced by any other group then it is what beta electrophilic substitution clear
Yes, sir.
okay now I have taken what for Friedel-Crafts alkylation I have to take alkyl halide अच्छा ये AlCl3 क्या करेगा बोल बेटा अरे what is the role of AlCl3 Rhea
It supplies electrons.
no it generates electrophile baby look ये इसके
Oh,
साथ ये
yeah, yeah.
it will take up both the electron and it will become AlCl4 minus or not and this methyl will develop positive charge or not so it is carbocation कैन यू सी अरे अल्काइल हैलाइड को मैं ऐसे लिख सकता था कि नहीं RCl देख रहा है बेटा
Yeah.
तो both the electron will be taken by AlCl3 why because it has incomplete octet and it generates the electrophile okay now what is
Hmm.
the name of the product here beta benzene से क्या बन गया मिथाइल बेंजीन so methyl benzene is also called toluene what is the
Hmm.
role of AlCl3 it helps to generate electrophile who is the electrophile carbocation clear
Yeah.
now we are going for Friedel-Crafts acylation. Now what you will say sir what is acyl? अच्छा this CH3 C double bond OH होता तो ये acetic acid होता था कि नहीं? So if I remove this OH, so this group is known as acyl group or acetyl group. And if I write here chlorine, then it is known as acetyl chloride. What is the name of this reactant? Acetyl chloride. Or I can take acetic anhydride. देख बेटा ये दो एसिड में से पानी निकाल देंगे तो क्या हो गया एनहाइड्रस so this is acetic anhydride so for Friedel-Crafts acetylation we need either acetyl chloride or acetic anhydride look here चिन्मय बेटा यहाँ पर देख बेटा मैंने क्या लिया है हेलो चिन्मय बेंजीन है कि नहीं बोल बेटा
हाँ सर।
और ये क्या है एसिटाइल क्लोराइड इसका IUPAC नेम होता है इथेनॉइल हाँ ये एरर है बेटा इथेनॉल क्लोराइड लिख दिया इथेनॉइल यहाँ पे OL आता है YL लिखना भूल गए वहां पे लिख दो बेटा OYL इथेनॉइल अल्केनॉइल क्लोराइड अच्छा चिन्मय व्हाट इज द रोल ऑफ AlCl3 AlCl3 क्या जनरेट करेगा बोल बेटा
सर इलेक्ट्रोफाइल।
हाँ तो ये दोनों इलेक्ट्रो ये क्लोरीन को खा जाएगा पूरा और तो AlCl4 बन जाएगा दिखाई दे रहा है देखना ये दोनों
हाँ
इलेक्ट्रॉन को खा और यहाँ पे अभी क्या हो जाएगा ये वाले पार्ट पे क्या चार्ज डेवलप हो जाएगा पॉजिटिव व्हाट चार्ज इट विल डेवलप ये एसिटाइल ग्रुप देख यहाँ पे आ जाएगा ठीक है ना बेटा अरे ये H और ये Cl चला गया देख HCl बना के नहीं और ये
हाँ
वाला
सर।
ग्रुप है वो इधर पे आके चिपक जाएगा देखना C डबल बॉन्ड OCH3 ठीक है इसको
हाँ
बेटा क्या कहते हैं हम लोग बेटा एसिटोफिनोन कीटोन है बेटा ये C डबल बॉन्ड ओ कीटोन होता है कि देखिए फिनाइल है तो फैन ये एसिटाइल ग्रुप था और कीटोन था तो एसेट फेनोन या फिर इसका कॉमन नेम क्या है बोल बेटा यहाँ पर कौन है मिथाइल ये क्या है फिनाइल मिथाइल फिनाइल कीटोन हु इज द इलेक्ट्रोफाइल हियर एसिलियम Here, who is the electrophile? Acylium. Clear. Now, beta, I am going to do, instead of acetyl chloride, I am going to use acetic anhydride. I am going to use acetic anhydride. Zoya, beta, this is acetic anhydride. Okay. Now, again, I am taking anhydrous, this thing. So, what will happen, beta? Here, this part will go. So, what I'll get, Zoya, CH3COOH. Can you see? And this acylium ion will attach in place of hydrogen. This. Look, इधर पे चिपक जाएगा देख रहा है एसिलियम I get acetophenone. Clear. Why the name I have given to this acetic anhydride? If I take two molecule of acetic acid, can you see? Okay, two molecule of acetic acid. उसमें से मैंने पानी निकाल दिया तो ये O बीच में आ जाएगा इसको कहते हैं एसिटिक एनहाइड्राइड क्लियर राइट
Yeah.
या सो वी डिड ऑल दिस नाउ बेटा इसका जो केमिकल ये वाला जो अदर रिएक्शन है वो आज मैं नहीं कराने वाला बट आई जस्ट टेल यू बेटा व्हाट वी डिड Look, we did a flow chart for this, beta. We did a flow chart for this. I'll show you. Oof, oof. Good 2025 hydro carbon. I have not done the, you know, other benzene derivative reaction. I've done only benzene ka. हाँ, look, beta. Today we did this, beta. Benzene. Look, Rhea, beta, can you see this? Hello, Rhea.
Yes, sir.
ये देख तीन एसिटिलीन लेके बेंजीन बना था कि नहीं बोलो साइक्लिक ट्राइमराइजेशन देन बेटा दिस राइट एंड देन रिडक्शन ये प्रिपरेशन है बेटा कैन यू सी हेडिंग इज प्रिपरेशन नाउ टुडे वी डिड एडिशन रिएक्शन और नॉट टेल मी हेलो
Yes, sir.
हाँ तो देख बेंजीन के अगर तूने क्लोरीन डाला तो हम लोग को ये मिला था कि नहीं बेंजीन हेक्साक्लोराइड हाइड्रोजन ऐड किया था तो क्या बन गया था साइक्लोहेक्सेन फिर ये ओजोनोलाइसिस कैन यू सी दिस बेटा हेलो दिस थ्री वेर
Yes, sir.
एडिशन रिएक्शन देन बेटा वी डिड दिस वाज इलेक्ट्रोफिलिक देखना बेंजीन का एच के जगह पे कौन आ गया क्लोरीन क्लोरोनियम इज द इलेक्ट्रोफाइल हियर इट वाज हु ब्रोमीन ब्रोमोनियम देन वी डिड व्हाट बेटा लुक हियर if I take excess chlorine beta we took excess chlorine we got hexachlorobenzene or not benzene say right tell me then we did this nitration nitrobenzene I got or not. Then I did sulfonation in this in nitro. Who was the electrophile here in nitronium? When benzene sulfonic acid you get who is the electrophile? Only sulfur trioxide. Then we did Friedel-Crafts alkylation. Toluene we got or not? Tell me. Then we did beta Friedel-Crafts acetylation by using acetyl chloride. Again acetylation by using acetic anhydride. Right? And last one is any hydrocarbon beta when you heat it in presence of oxygen, what you will get? You always get carbon dioxide, water and heat. Now you tell me beta, how will you balance this Rhea? I gave you the trick, remember? अरे बेटा भूल गई क्या?
Yeah.
CXHY plus O2 gives you CO2 plus H2O.
Yeah, and y/2 and x.
Ah, so here, what is the value of your X here? X है तो यहाँ पे क्या लिखते थे X. Y
X.
is what we write y by 2. Then what you have to do, whatever O is there on the right hand side, we write half of that, half of O on right hand side. So what is the value of X here, Rhea?
6.
So I'll write here 6. What is the value of Y?
6. So 3.
Y by 3, Y by 2, so 3. How many O are there here? Count 6 into 2, 12.
12.
12 plus 3.
15.
So what I'll write 15 by 2. Understood?
Yeah.
So this is all about your look here. So we got the same thing here. Can you see this beta? देख रहा 6 3 15 by 2. Hello.
Yeah.
Have you understood this trick? चिन्मय बेटा समझा क्या ये? हेलो.
हाँ सर.
So yeah, have you understood this beta? Right? Now on Thursday beta we will do the last part of this chapter, that is the benzene derivative के reactions. Okay? Clear? Bolo bhai. Benzene derivative means which one? You will say, sir, what are benzene derivatives? So look, I want to do, I will just show you this. We are not going to do this, but that are very important beta. Derivative of benzene. So that we have to do beta. Look, we did beta this Friedel-Crafts acylation, alkylation, all this reaction, nitration, we did. Look, I have given you the mechanism also beta. Look, can you see what was the role of AlCl3? It generates electrophile, then how it attacks, right? Okay. So that's all for today. Chalo then. Bye-bye everybody. Bye-bye.
Sir, I won't be able to join this Thursday also because I have extra class
Which class?
for my entrance exam.
Oh my God. But beta, that Thursday I have to take very important. What time you will get? What time you have exam?
7 to 9.
So before that, are you free?
No, sir, I
Okay.
have physics
I'll
test.
message. I'll message. Don't worry. I'll message. Okay.
Okay, you can just send me the recording. I'll watch
Yeah,
the
yeah. Okay,
recording.
okay. I'll do that. Chalo then. Bye-bye.
Thank you, sir. Bye.